Let's talk now about the asymptotes. What is an asymptote? Okay, so the asymptote is what we were seeing on that graph where the graph does not pass. So the vertical asymptote is a vertical line. A vertical line is always in the form of x equals a number. That's why this says x equals c, c being an arbitrary number, a constant. Okay, and that is going to form a vertical line that the graph of the function approaches but does not touch. The restriction of the domain are candidates for vertical asymptotes. What does that mean? It means when we were looking here at the restriction of the domain, because I cannot use x equals -4, what happens to the graph at that point? Well, what happens is the graph freaks out, okay, and it cannot cross that line, x equals -4, and we're going to see that when we graph in a moment. Then you have a horizontal asymptote. It's a horizontal line, so that's why it's y equals b, and b in this case is just a different number than c, still a constant though. So you have a horizontal line, right? Horizontal line looks like this, vertical line looks like this. And the graph of the function approaches for large or positive negative values of x. This is considered the end behavior of the graph. The end behavior, it kind of is it's a calculus type concept. So this is a little bit more tricky, but essentially if we look at the degree of the numerator and the degree of the denominator, if the degree of the numerator is less than the degree of the denominator, so for example, let's say the degree of the numerator is 8, or sorry, the number of the numerator is 8. What's the degree of the number 8? With no variable. It's actually the degree is 0. If there's no variable, the degree is 0. What's the degree of the denominator? Yes, x to the first has a degree of 1. So that's why when we were looking at this first example on our graph, the horizontal asymptote was y equals 0. Y equals 0 is the same exact equation as the x-axis. That's because the degree of the denominator was less than the degree of the numerator. And essentially what we were just talking about is the idea is if you had $8 and you're dividing it by a certain number of people, like if I have $8 and I just divide it by one person, then I get to keep all of it. As soon as we have $8 divided by 2 people, now we split it in half. $8 divided by 4 people means each of us gets 2. $8 divided by 8 people means we get $1 each. You can never, even though you're going to continue dividing up that $8 by a certain number of people, if we said $8 divided by 1,000,000 people, how much money is each person getting? $8 divided by 1,000,000. Way less than a penny, but it's not 0. Okay, if we took 8, let me quit that, 8, and we divide it by 1,000,000, 10 to the 6th power, is that 6 zeros, something like that, we get, that's scientific notation for 8 millionths, okay, which is a really, really small number. So the idea is that this graph is approaching 0, but it's never going to reach 0. And remember what we said about the restriction on the domain. What number could we not use in the denominator? 0, right? That restriction on the domain, x equals 0, is the equation of the y-axis, and that gives us the vertical asymptote. Okay, that's where the graph cannot cross. If the degree of the numerator and denominator are a match, then we would take the ratio of the leading coefficients. Okay, I'll show you this in the next examples. So let's look at example 6. State the domain and the vertical asymptote. By the way, they're the same thing. Except, well, I guess they're opposites in a way. We said the domain here, what number can we not use that will give us 0 in the denominator? Yes, so x cannot equal -4. Well, that means that the vertical asymptote, I'm just going to use VA for short. This is domain. The vertical asymptote is therefore x equals -4, because what's going to happen is the graph is going to sort of freak out around there and it cannot cross that line. Okay? What's the domain for the next one? X such that x cannot equal, what number would give us 0? It'd be +2, right? 2 minus 2. And so what's the vertical asymptote? X equals 2. Yeah, and it's going to be an actual vertical line, so it always has to start with x equals. What's the domain for the next one? X such that x cannot equal 4. So what's the vertical asymptote? X equals 4. Here, same thing. What would give us 0 in the denominator? Cannot equal 4. And so therefore the vertical asymptote is x equals 4. Okay, so for the horizontal asymptote, that's where it gets a little trickier. We have to look at the relationship between the numerator and the denominator. So the degree of the numerator is what? 0. What's the degree of the denominator? And that D looks like domain, but it's degree. So since the degree of the numerator is smaller than the degree of the denominator, what's the horizontal asymptote? It's always going to be y equals 0 if you look back at that definition. Okay, so what's the horizontal asymptote here? Y equals 0, good. Now, when we look at, basically, if you think about this as n behavior, what happens as x gets really big? Let's say we were to find f of a million, okay? And I'm just going to approximate. Essentially, that's going to be 2,000,008, right? Divided by 1,000,000 minus 4. So since the degree of the numerator is 1 and the degree of the denominator is also 1, we're going to look at the relationship between the coefficients. Essentially, what's 2,000,000 divided by 1,000,000? Yeah, it's actually 2. It's just taking 2. If they both have x's, we're just going to divide the coefficients. 2 divided by 1 is 2. Here, we're going to have x divided by -x, because these both also have degree of 1, degree of 1. So what's 1 divided by -1? -1. So we're looking at anytime you have an x in the numerator and denominator and they both have the same degree, you'll look at the coefficients of the leading coefficients, and you'll compare those two numbers. Okay, so now we can put this all together into a few graphs. In fact, why don't I stop this? We'll start a new one.